Hi everyone, my name is Angel. Let's start with content category 4A, translation motion, forces, work, energy, and equilibrium in living systems. This is going to be based out of the outline that's created for AAMC for MCAT. Okay, so let's start with 4A, that's translation motion, right? And this is going to be covered in physics. In this video, we are going to cover MCAT physics, right? Alright, so what are units and dimensions? Units are standard measures used to express physical quantities such as meters for length, kilograms for mass, and seconds for time. Dimensions describe the basic nature of these quantities in terms of fundamental physical ideas like length, mass, and time. Okay? Using dimensions helps check whether an equation is physically meaningful and allows conversion between units, right? So this is going to be very important part for MCAT. You know, the conversion part is going to be incredibly important, all right? Because many of us struggle with doing calculations without calculator. So this is where you'll have to focus on, especially with questions like these, right? Dimensional analysis also makes it easier to understand how different physical quantities are related and how changes in one quantity can affect another, right? So that's very important. For example, the quantity is force, the unit is Newton, right? The SI breakdown would be 1 Newton is equal to 1 kg into meter per second square, right? So work and energies are calculated in joules, right? So 1 joule is called 1 Newton meter, which equals to 1 kg into meter square per second square, right? So power is watt, pressure is Pascal, right? We're going to learn about Pascal's law. Frequency is hertz, 1 hertz is equal to 1 by second. Charge is coulomb, right? So 1 C is equal to 1 ampere into second. Voltage is volt, 1 V equals to 1 joule per coulomb, right? Or equals to 1 kg meter square plus second cube into ampere, all right? So resistance is ohm, right? So 1 ohm equals to 1 volt by A, right? Okay, so capacitance is farad, right? So 1 farad equals to 1 coulomb per volt, right? Magnetic field is Tesla, right? So 1 Tesla equals to 1 Newton per ampere into meter, all right? So like that. You have to remember all these, and even the numbers, the power of 10 is also very important. Tera is 10 raised to 12, giga is 10 raised to 9. Remember the pen drives, gigabytes. Mega is 10 raised to 6, yeah? Remember megalodon, you know how it was shaped. Kilo is 10 raised to 3, it's easy. Centi is 10 raised to minus 2. Remember that centi right here is where the minuses start, right? 1 centimeter equals to 10 raised to minus 2 meter. All right, so milli is 10 raised to minus 3, micro is 10 raised to minus 6, mu, nano is n 10 raised to 9, right? Minus 9. Nano must be very easy. Pico is 10 raised to minus 12. Femto is 10 raised to minus 15. They usually don't go below pico or femto. They usually surround themselves with a giga or mega or kilo, centi, millo. Micro, sometimes they may ask nano. Yeah, that's like the favorite. All right, so how do you convert 12 meter per second to kilometer per hour, right? So just write down the quantity that you need to convert, right? Remember the units. 1,000 meters equal to 1 kilometer, right? We just saw 10 raised to 3, right? 3,600 seconds equals to 1 hour, right? We have 60 minutes in an hour, right? All right, so 12 meter per second, we have to convert that, right, into 1 kilometer plus by 1,000 meter into 3,600 seconds by 1 hour, all right? So M cancels and S cancels, right? So now we have 12 into 1 by 1,000 into 3,600, right? So all you have to do is just cancel 2, right? 12 into 36 by 10. So now we have 43.2, right? So it's not, so that's 43.2 is the kilometer per hour, all right? All right, so basic trigonometry table is very important. You usually do get asked for sine theta, cos theta, tan. They don't ask this part, cot, you know, they don't ask sec theta. I've never seen a question being asked like that, right? I haven't given my MCAT yet, but I haven't really seen it in any of the trainings that I've had, right? So sine 30, these are the angle rads. You know, sine 30 is half. Sine 45 is root 2 by 2. Sine 60 is root 3 by 2. Sine 90 is 1. Cos theta Theta is an angle. Cos 30 is root 3 by 2. Remember, cos 45, right, is root 2 by 2. It's the same. As you can see, sine theta, cos theta is the same, right? Cos 60 would be half, right? Tan 60 would be root 3. Tan 45 would be 1. Tan 30 would be 1 by square root of 3, right? So this part they usually don't ask, right? So if you can see this area, let me just use a little table here. Anything from here they don't ask, you know. I haven't seen a question about it. Vectors are quantities that have both magnitude and direction. Examples include displacement, velocity, and force, right? So displacement, velocity, and force are vectors, right? Scalars, they don't really show direction. They only show magnitude. To make calculation easier, a vector can be broken down into components, usually along the x and y axis, right? We've seen x and y axis mostly, especially when it comes to vector addition. That's when you'll have to use x and y axis. Right, so these components represent how much of the vector acts in each direction. Working with components helps simplify the problems, especially when vectors are not aligned with standard axis or when multiple vectors act at different angles, right? So that will happen, especially when you use the parallelogram method for analytics, right? Vector addition is a process of combining two or more vectors to find a single resultant vector. This is also very important. Resultant, the R vector is important. The most common method is head to tail, right? Head to tail, connect one's head to tail, right? This method is very common. The resultant vector is then drawn from the starting point of the first vector to the ending point of the last. This is also very important. Mathematically, vectors can also be added by simply adding their corresponding components along each axis. You can just add them, you know, mentally. This method is especially useful in physics problems involving forces, motion, or any situation where multiple influences act simultaneously. It's simultaneous. It's not one after another, right? So triangle method. So this is the triangle method. Step 1, link the vectors head to tail. Step 2, from the resultant vector from linking the tail of the A to the head of B. A, B, as you can see, this is A, that is B, and this resultant vector is C. All right, so C equals to A plus B. The parallelogram method is also very important. Link the vectors tail to complete the resultant parallelogram, right? So this is the parallelogram, right? Two parallels, one diagonal, right? The resultant vector is the diagonal. C here is the resultant vector on both the sides, and that is the R, okay? There you go. So break each vector into components. So this is the analytical method, right? AX is called A cos theta. AY is called A sine theta, right? So AX equals to A cos theta, right? AY, x-axis is A cos theta, and AY is sine theta, okay? Add components separately, AX plus BX, RY, AY plus BY, and compute the magnitude. R is equal to RX squared plus ry squared and the square root of both the additions, right? So theta is equal to 10 raised to minus 1 ry by rx, all right? Resultant vector, ry by rx, 10 raised to minus 1, okay? Speed and velocity, average and instantaneous velocity, okay. Speed is the rate at which an object covers distance and is a scalar quantity, meaning it has only magnitude, all right? This is not displacement. This is not velocity. Velocity is a vector. Velocity describes how fast an object changes position, also includes direction, making it a vector quantity. Average speed or velocity is calculated by dividing the total distance or displacement by the total time taken. Average speed is total distance by total time taken. Instantaneous speed or velocity refers to the value at a specific moment in time, such as what you would read on a speedometer, right? So instantaneous speed or velocity refers to the value at a specific moment. So your speed at a bump would be different than speed at, let's say, going north. Let's say you're going straight and there is no bumper, and the speed would increase, right? So that's it. It's just a magnitude at a particular time. Instantaneous values show the exact behavior of an object at a particular point in its motion, right? So velocity, instantaneous velocity is derivative of the position with respect to time. If a body's position at time t is s equals to function t, then the body's velocity at time t is vt is equal to ds by dt, limit delta t to 0, f, the function t plus delta t, the change in time, minus function of time by delta t, all right, the change in t, all right, the change in time. Acceleration is the rate at which velocity changes with time, because velocity has both magnitude and direction. Acceleration can occur when an object speeds up, slows down, or changes direction. Okay, so because velocity has both magnitude and direction, acceleration can occur when an object speeds up, slows down, or changes direction. If you're going from north to south or north to east, chances are your speed is going to change. You're not going to be going on the same velocity, right? So at times object can speed up, the magnitude of the speed may increase or slow down. The acceleration can be minus as well. You're going for 50 miles per hour, all of a sudden you see a car that's stopping in front of you, or you may start slowing down by 30 or 20 miles per hour, etc. It's a vector quantity and plays an important role in describing motion under forces. All right, the force here would be you pumping the brake pedal, right? When acceleration is constant, motion becomes easier to analyze using uniform motion equations, right? If the acceleration is constant, right? So let's say you're pushing something and it has been a constant, right? There is no additional force. Uniform motion equations are much more easier. When acceleration changes, more detailed mathematical methods such as calculus are needed to describe the motion accurately. All right. So acceleration formula, A is equal to delta V by delta T. Delta V is change in velocity, meter by second. Delta T is change in time. Acceleration is meter by second square. All right. Force is a physical. What is force? Force is a physical interaction that can change the motion of an object. It can make an object start moving, stop, speed up, slow down, or change direction. Force is a vector quantity, meaning it has both magnitude and direction, and it is measured in newtons, right? It results from interactions such as pushes, pulls, gravity, friction, or tension, right? As you can see, this is force. You're pushing the block formula, F is equal to ma, mass into acceleration. All right. Newton's first law in inertia. This is very important. This is high yield for MCAT. First law in inertia, Newton's first law says an object will not change its motion on its own, right? If the book's on the table, it is not going to move on its own, right? If it is at rest, it will stay still, and it's moving, it will keep moving in a straight line at the same speed. Unless an external force acts on it, this idea is linked to inertia. Whatever is still will stay still until there's a force that pushes it, backward, forward, down, up, etc. Which is the resistance an object has to change in its motion? Which is the resistance an object? So inertia is nothing but a resistance, okay? Objects with more mass have more inertia, so they need a larger force to start moving, stop, or change direction, right? You will need more or a larger force to push 100-kilogram block versus 20-kilogram block, right? When you pick up dumbbells, right, that are like 100 kilograms, or even if you can 50 lbs, chances are you'll need more force to crunch your muscles, right? So that's what they're saying. Newton's first law of motion inertia: an object will not change its motion unless acted on by an unbalanced force. If it is at rest, it will stay at rest. If it's in motion, it will remain at the same velocity. Okay. Objects with a greater mass have more inertia. It takes more force to change their motion. This is 300 kilograms. This is 30 kilograms. Okay. It takes more force to change their motion depending on the mass. More mass, more force. All right. That's why they say F is equals to ma. Right. Newton's second law describes how force affects the motion, right? So it states that acceleration of an object depends on two things: the net force applied to it. The net force, we're talking about the net force, all right? Remember that. F equals to ma explains the relationship for where force equals mass multiplied by acceleration. This means that if we apply a stronger force, the object accelerates more, and if the object has larger mass, it accelerates less for the same force, right? That's true. This law helps us understand how objects respond when different forces act on them, right? Newton's third law, equal and opposite forces. Newton's third law states that every action has an equal and opposite reaction. This means that whenever one object applies a force on another, the second object applies an equal amount of force in the opposite direction. This force also always comes in pairs. Equal and opposite comes in pairs. There are two forces working on, right? For example, when you push against the wall pushes back with the same strength, right? Even though the forces are equal, they act on different objects, so they do not cancel each other out, right? So you're pushing the wall is pushing towards you. You're not canceling each other out, you know. So F12 equals to minus F21. Okay, that's what Newton's third law states. F12, the force exerted by object 1 on object 2. Excuse me. F21, the force exerted by object 2 on object 1. The negative sign means the forces are equal in magnitude and opposite in direction. The forces are equal in magnitude but opposite in direction. That's the meaning of the negative sign. For every action force, there is an equal and opposite reaction force, right? All right, so most of the times the questions that may be asked will be around this. Force act on different objects, not the same one. They will confuse you because they want to see the logic behind the third law, all right? The forces act on different objects, not the same. They occur simultaneously and not sequentially, right? All right. They do not cancel each other because they are not applied to the same body. You're forcing the block's forcing on you. The two bodies are not the same, all right? So they do not cancel each other out, all right? One's positive, one's negative. F12 equals to minus F21, all right? Friction, what is friction? Static and kinetic friction. You will be asked questions because this is a very high yield. Friction is a force that opposes motion between two surfaces that are touching each other. Right, so for friction, it's important that you have two surfaces that are touching each other. They also come in pairs. Static friction acts when an object is not moving, right? So static friction, when it's kinetic friction, that is moving. Static friction is not moving. It prevents the object from starting to move and increases with the applied force up to a maximum limit. So it prevents the object from starting to move, static friction, okay? Kinetic friction acts when the object is already moving and works to slow it down. Kinetic friction is usually lower than static friction, right? So Fk is less than Fs, which is why it's harder to start moving an object but easier to keep it in motion, right? When you have to force a block, then chances are you have to exert force, right? When it's in motion, it's easier. You know, with a little amount of force or constant force, you can keep it in motion, right? You don't have to exert that much amount of force, right? So Fk is usually less than Fs because static friction is greater than Fk. Friction is important in everyday life because it allows us to walk, hold objects, and use machines safely, right? So that is static friction. That is applied force Fa. Box remains stationary. Static friction, right? So block is also pushing towards the person, right? Kinetic friction. The applied force, kinetic friction, is also pushing towards, right, the person. Box moves towards right. Static friction, the box is not moving, right? That's why we say it's larger, right? Friction equation, F friction equals to move Fn, right? So this is the net force, the net friction equation. So Fs is equal to mu s by Fn, right? Kinetic friction is Fk equals to mu k by Fn, right? Multiplied by Fn, right? Net force, all right. The center of mass is a point. This is also a very high yield, okay? Center of mass is the point within an object or system where its entire mass seems to be concentrated. The center of mass is a point within an object or system where its entire mass seems to be concentrated. Remember that. It represents the average position of all the mass in the body. It talks about average mass. All right, when forces act on an object, the motion of the center of mass helps us understand how the object will move or balance. All right, for example, an object is more stable when its center of mass is low and directly above its support base. Studying the center of mass also helps in analyzing rotating bodies and systems with multiple parts, right? So studying the center of mass also helps in analyzing rotating bodies and systems with multiple parts, right? Center of mass, the more generalized definition for two particles, right? X, the center, m1 x1 plus m2 x2 divided by m1 plus m2, all right? Note that if x1 equals to 0, we are back to the previous equation, right? So this is x, m1, m2. This is d, right? This is x1 and x2, right? So this is the center. Now d will be the displacement, okay? So m1x1 plus m2x2 by m1 plus m2. Equilibrium in physics refers to the state in which all the forces and torques acting on an object are balanced, resulting in no change in its motion. Equilibrium in physics. All right. So it is a state where all the forces and torques, we'll be learning about torque pretty soon, acting on an object are balanced, resulting in no change in its motion. Equilibrium is everybody's relaxed and chill. Okay. There is no change in its motion. This means the net force on an object is zero, so it remains at rest or continues moving with constant velocity. Right? In rotational equilibrium, the net torque is also zero, preventing any rotation. Overall equilibrium ensures the object stays in a stable and unchanging state. All right, so equilibrium ensures the object stays in a stable and unchanging state. So it's important. Equilibrium is asked, but mostly kinetic and static friction questions are asked, or the three laws of Newton's, or vector, scalar, displacement, distance, etc., etc. All right, so vector analysis of forces acting on a point object. In equilibrium, the forces acting on a point object must balance each other so that the object remains at rest or moves with constant velocity. Right? So how do you analyze a vector of forces acting on a point object? Right? Since forces are vectors, they have both magnitude and direction. To analyze, each force is broken into components x and y. Right? By adding these components, we determine the net force, right, or equilibrium of all forces in every direction must be zero. This method of resolving and adding vector quantities components allows us to understand how multiple forces interact and ensures that the object stays in stable and balanced state. All right. So resolving adding vector components helps us understand how multiple forces interact and ensures the object stays in stable and balanced state. So just like all living systems, as you can see, equilibrium is given very important with vectors, right? Or at least understanding of equilibrium, right? So torques and lever arms, this is also extremely high yield for MCAT. Torque is a rotational effect of force acting on an object. It depends on two factors, magnitude of the force and lever arm, which is the perpendicular distance from the axis of rotation to the line of action of the force. All right. So lever arm, which is the perpendicular distance. All right. Remember that. A larger lever arm or a stronger force produces a greater torque. All right. So a larger lever arm would produce a larger torque. All right. A greater torque. For an object to be in rotational equilibrium, the sum of all clockwise torques must equal the sum of all counterclockwise torques, right? So sum of all clockwise torques must equal the sum of all counterclockwise. So clockwise, counterclockwise, it has to equal, all right? For an object to stay in rotational equilibrium, right? So it means to stay in motion without any force. Net force equals to zero. All right. This balance prevents the object from rotating. Understanding the torque and lever arms is important in studying seesaws or gears, wrenches, and any situation where rotation or turning forces are involved. Unit of torque is Newton meters, right? So for example, torque equals to tau, that's what they call it, RF sine theta, right? So lever arm is measured from the axis of rotation, right? This is the axis of rotation, all right? Now here we see R, that is a radius from axis of rotation to the point application of the force. This is the applied force, right? Point of application of the force. This is the radius. This is the lever arm is measured from the axis of rotation, right? So this is lever arm equals to R sine theta. This is the angle theta, right? So this is the R sine theta. This is the R, and this is the applied force, right? Work in physics is the energy transferred to an object when a force causes it to move, right? The energy transferred to an object when a force causes it to move, right? So work in physics, the energy transferred. Work is nothing but an energy, right? Work is done only when the applied force has a component in the direction of the object's displacement. It is measured in joules. Work is measured in joules, right? If there is no movement, or if the force is perpendicular to the motion, no work is done. If there is no movement, right, or if the force is perpendicular to the motion, no work is done, right? Work done by a constant force, Fd equals to cos theta. All right, when constant force acts on an object and causes displacement, the work done is given by W equals to FD cos theta, all right, cosine theta, where F is the magnitude of the force, D is the displacement, and theta is the angle between them, right? Only the part of force that acts along the direction of displacement contributes to work, all right? Acts along the direction of displacement. It's not perpendicular, right? Only the part of the force that acts along the direction of displacement contributes to work, right? If the force and displacement are in the same direction, the work is maximum along the direction, right? If they are perpendicular, the work becomes zero, all right? So if if the if the force and displacement are in the same direction, the work is maximum. If the force and displacement are perpendicular, the work becomes zero, right? The formula for work, FD cos theta, the unit of force is Newton, unit of distance is meters, right? The unit of work is Newton meters. 1 Newton meter equals to 1 joule, right? So the unit of work is 1 joule, right? Mechanical advantage, this is also a very high yields topic. Mechanical advantage describes how effectively a machine multiplies an applied force, right? It is defined as a ratio of output force, the force machine exerts, to the input force, the force you apply. Higher mechanical advantage means the machine makes tasks easier by allowing a smaller input force to achieve a larger output force. Common devices that provide mechanical advantage includes levers, pulleys, and inclined planes, right? All right, the core definition, mechanical advantage equals to output force by input force. And the input force is the force that we apply. MA equals to F out by F in. Right, distance or displacement. For ideal machines with no friction, MA is equal to D in by D out. This is a generalized formula. Because work in equals to work out, and that is an idealistic system. Lever mechanical advantage, length of the effort arm, right, we just learned, by length of the resistance arm, right? So length of the effort arm and the resistance arm, okay? Pulley systems, MA equals to number of supporting rope segments, right? So that's a pulley system. Inclined plane, length of plane by height, length of the plane by height, right? So that's a inclined plane. Wheel and axle, radius of the wheel by radius of the axle, all right? So that is also a mechanical advantage. Why? Because this is the output, this is the input. Length of the plane would be output, height would be the input, right? For pulley system, it's very simple. MA mechanical advantage equals to number of supporting rope segments, right? Work kinetic energy theorem. This is also very important. This theorem states that the net work done on an object equals to the change in its kinetic energy, right? So W equals to KE. This means that work is done on an object, its motion changes. Positive work increases the object's kinetic energy, making it speed up, right? So positive work increases. Negative work decreases the kinetic energy, causing it to slow down. This theorem provides a clear connection between force, work, and motion of an object. All right, so work kinetic energy theorem, the transfer of energy that leads to something to move, right? So if the work done is positive, it will increase the kinetic energy. If the work done is negative, it will decrease the kinetic energy, right? So this theorem provides a clear connection between force, work, and the motion of an object. What are conservative forces? A conservative force is a force for which the work done depends only on starting and the ending position, not on the actual path taken. All right, so conservative force is the work done depends on starting and the ending position. Examples include gravitational force and the spring force. For a conservative force, the total work done in a closed loop is zero. All right, so the total work done in a closed loop is zero. These forces are linked with potential energy, meaning energy can be stored and fully recovered without any loss. All right, this property makes conservative forces important in the study of energy conservation. Energy of point object system. Energy of point object systems refers to the total mechanical energy associated with a single object treated as a point mass. This energy comes from the object's motion and its position in a force field, right? The energy of a point object system refers to the total mechanical energy associated with a single object treated as a point mass. This energy comes from object's motion and its position in the force field. All right. It mainly includes kinetic energy, which depends on the object's speed, and potential energy, which depends on the position or configuration. The study of point object energy helps describe how energy is stored, transferred, and conserved in simple mechanical system, right? So this is very important. Law of conservation is how energy is stored, transferred, and conserved in simple systems, right? Ke is equal to half mv square, or kinetic energy is the energy of an object has due to its motion. It depends on the mass of the object and square of its velocity. The formula is Ke equals to half mv square, where m is the mass and v is the velocity. Because velocity squared, even small increases in speed greatly increases the Ke. The SI unit of Ke, because it's energy anyways, it's joule, right? Ke increases when an object moves faster and becomes zero when the object is at rest, right? All right, the potential energy, all right, PE. The potential energy is stored energy an object has because of its position, or configuration, right? So it can be converted into Ke with when the object begins to move, right? Potential energy, that's why we usually say the potential energy is dependent on kinetic energy, right? A lot many people, you will hear them say that because it's converted when it starts moving, right? Two common types of potential energy are gravitational potential energy and elastic spring potential energy. Okay, so there are two types, gravitational or spring potential energy. Gravitational potential energy, PE equals to mgh. Gravitational potential energy is the energy stored in an object due to its height above a reference point. It is given by PE equals to mgh, where m is the mass, g is gravitational acceleration, h is height. For MCAT, we usually use 10 meter per second square, the gravitational, right? As height increases, the gravitational potential energy also increases. This form of energy can be converted back into motion when the object falls, right? All right, so spring potential is PE equals to half kx squared. The spring potential energy is stored when a spring is stretched or compressed. It is given by PE equals to half kx squared, where k is the spring constant, x is the amount of stretch or compression. The more the spring is deformed, the more energy it stores, right? So K is the spring constant, a measure of stiffness, whereas X is the amount of stretch or compression, right? Conservation of energy. The principle of conservation energy states energy cannot be created, destroyed. It can only change from one form to another in a closed system with no external forces. The total energy remains constant. This means that sum of Ke and Pe stays the same even though one form may convert into another. Right, so they may stay the same in a closed system. For example, as an object falls, its PE decreases while its kinetic energy increases, but the total energy remains unchanged. PE equals to Ke, right? But the total energy is remaining unchanged, right? So there you go. Conservation of E, core equation E initial equals to E final, right? Expanded into mechanical, Ki plus Ui. U is the potential energy equals to Kf plus Uf, right? So Kf, initial kinetic state versus final state, okay? As you can see, they're equal, which means they're the same. When non-conservative forces like friction are present, right? So that would be changed. Now work done by non-conservative forces, that would be an addition, equals to Kf plus Uf, right? The final state and the initial state, right? All right, the power is the rate at which work is done or the rate at which energy is transferred. It tells us how quickly energy is used or converted. The power is given by the formula power equals work by time, or P equals to dE by dt. All right, power is the rate at which the work is done or the rate at which energy is transferred. So power is nothing but a rate, right? It tells us how quickly energy is used or converted, right? Power is given by the formula P equals to W by T, or P equals to dE by dt, all right? SI unit of power is watt. 1 watt equals to 1 joule per second, right? A higher power value means that the work is done faster or energy changes more rapidly. What is periodic motion? Is a type of motion that repeats itself at regular intervals. All right, so periodic motion repeats itself as regular intervals. An object in periodic motion returns to the same position and state after a fixed time called period. So after, let's say, 1 minute, it returns back to its state. That's periodic motion. Examples include a swinging pendulum, vibrating springs, and oscillating masses. This type of motion helps describe many natural mechanical systems that follow repeating patterns, right? Amplitude, frequency. Amplitude is the maximum displacement of the object from its equilibrium rest position, represents the strength or intensity of the wave. A larger amplitude equals to more energy, right? Units depend on the wave type. Meters, mechanical waves like water waves. Volts, electrical signals. Decibels, sound waves, right? It shows how far the object moves during its oscillation. So general wave equation, A sine Wt plus psi, or Y equals to A cos Wt plus psi. This particular formula is psi, psi, right? Amplitude, angular frequency, time, and phase shift. Peak-to-peak method. Peak-to-peak method, measure distance between the highest crest and lowest trough, divided by 2, right? So you can also calculate the amplitude by this particular formula. Frequency is the number of complete cycles or oscillation the object makes per second. It is measured in hertz. Higher frequency means more cycle in less time, right? It's frequency. Higher frequency is more cycles in less time. It's calculated in hertz. Frequency equation of wave is most commonly written as F equals to 1 by T, or F equals to V by lambda, right? So F equals to frequency, T time period, V equals to wave speed, and lambda wavelength. All right, so from time period, F is equal to 1 by T. From wave speed and wavelength equals to V by lambda. A sound wave traveling at 340 meter per second with wavelength 0.85 meter has frequency 340 by 0.85, 400 hertz. All right, so we are given velocity and we are given wavelength, so we just divide each other and we get 400 hertz, right? What is angular frequency relation? So W, angular frequency, equals to 2 pi f, okay, useful in oscillations and wave equations. If you want to calculate angular frequency, you can use this particular equation. Now this is angular frequency relation is high yield. All right, why frequency matters? Sound waves, it determines pitch. High frequency, like we said, is high pitch, right? It means light waves determines color. Red equals to lower frequency, blue equals to higher frequency. Electronics, frequency defines signal cycles per second, right? Signal cycle, electronic sound, electronic waves, right? 60 hertz AC power, right? Example, a wave has speed of 300, wavelength is lambda 2, 300 by 2, 150 hertz, right? So the wave oscillates 150 times per second. That's what it means. Frequency is either the reciprocal of time period or the ratio of wave speed to wavelength, right? Phase describe the position and state of the oscillating object at a particular moment within its cycle. It helps compare the timing of 2 or more oscillations. Transverse and longitudinal waves, wavelength or propagation speed. Transverse waves are waves in which particles of medium move perpendicular to the direction of wave travel. Examples, water waves, light waves, etc. Right? So transverse waves are waves in which particles of the medium move perpendicular to the direction of wave travel. Right? Longitudinal waves are waves in which particles move parallel to the direction of the wave propagation, right? So this is longitudinal and this is transverse, right? As you can see, this is perpendicular, whereas as you can see, this is longitudinal. Amplitude, this is expansion, this is compression. So there you go. This is parallel versus this is perpendicular. Just remember PT and LP, all right? So it will make it very easy for you. Wavelength is the distance between two corresponding points on the wave, such as crest to crest or compression to compression. Lambda equals to V by F, right? So wavelength is meter, V is wave velocity, meter per second, frequency cycles, or hertz. What is propagation speed? Propagation speed is the speed at which the wave travels through a medium. It is given by V equals to F lambda, right? So V equals to F lambda. So we just cross multiply. V equals to F lambda, right? And W is the wavelength. Sorry, lambda is the wavelength, right? So here we complete content category 4A. I'll be back with content category 4B. Thank you for watching. Bye.